In panel B, we'll start with the same initial setup, an initial blue budget constraint formed by an endowment of 60 leisure hours and a wage of $20 per hour, an original optimal bundle of A, and a new magenta budget constraint corresponding to a $25 wage per hour. The only difference with bundle A is that we now place bundle C to the left of bundle A. To isolate the substitution effect, we again introduce the green compensated budget constraint and its tangency with the original indifference curve at bundle B. Because we've kept the shape of the original indifference curve the same as in panel A, bundle B happens at exactly the same place as it did in panel A. In other words, the substitution effect in panel B is the same as it was in panel A. Furthermore, notice that as we go from bundle B to bundle C, and thus from the green compensated budget to the parallel magenta final budget, we're increasing our consumption of both leisure and other goods. Thus both leisure and other goods continue to be normal goods in this graph, just as they were in panel A. Since leisure appears on the horizontal axis of both the top and the middle graphs, we can once again drop the points from the top graph down to the middle graph. But we now have wage on the vertical axis, and so the height of the points will be determined by the wage that those points occur at in the top graph. Bundle A occurs at the original $20 wage, bundle C occurs at the final $25 wage. And bundle B similarly occurs at the $25 wage, since the green compensated budget has the same slope as the final magenta budget. The movement from A to B is then our substitution effect, just as it was in panel A. And because we've kept the shape of the original indifference curve the same, the size of the substitution effect is exactly the same. It once again tells the worker that as the wage goes up, he should consume less leisure because leisure has become relatively more expensive. The movement from B to C is our wealth effect, which again points in the opposite direction from the substitution effect, just as it did in panel A. This is because, just as in panel A, we're assuming that leisure is a normal good. The wealth effect just isn't as large as it was in panel A, and therefore doesn't overcome the entire substitution effect, leaving us with a net effect of the worker decreasing his leisure consumption as a result of an increase in the wage. Connecting points C and A, we once again get an estimate of the shape of our leisure demand curve, which tells us the relationship between the wage and the quantity of leisure demanded by this worker. In our case, an increase in the wage from $20 to $25 an hour causes the worker to decrease his demand for leisure from 20 hours to 15 hours per week. In other words, to increase his work effort by 5 hours per week. Recognizing that labor hours supplied is simply equal to 60 minus leisure hours demanded, we can then translate the points from the middle graph to the lower graph, where we put labor hours on the horizontal axis. 20 hours of leisure at point A translate to 40 hours of labor at point A in the lower graph. 15 hours of leisure at point C become 45 hours of labor, and 10 hours of leisure become 50 hours of labor. The substitution effect is still the move from A to B, and the wealth effect is still the move from B to C. They now point in opposite directions because we have labor rather than leisure on the horizontal axis. Connecting A and C, we then get our labor supply curve, the curve that illustrates the relationship between the wage and the quantity of labor that the worker chooses to supply to the market. The labor supply curve is now upward sloping rather than downward sloping as it had been in panel A. This is despite the fact that in both panels A and B, leisure is a normal good.